Welcome, good morning, and welcome to week 16 of our school readiness session since the week 4 or maybe 5 of our science and health. Kind of lost track there, but I'm glad you guys made it. What we'll do is we'll do our good morning song and go over our journal topic, and then I will go over the contents of our last go home bag, the last kit bag that we will be passing out because we're almost to the end of our session. So everyone, get your clapping hands out and let's shake them up. All right, we're doing a lot of space and space exploration, so let's shake off some of that moon dust. All right, here we go. Good morning, good morning. How are you? How are you? Very well, I thank you. Very well, I thank you. And you, and you. Buenos dias, buenos dias. ¿Cómo está? ¿Cómo está? Muy bien, gracias. Muy bien, gracias. Y ustedes, y ustedes. All right, so now's the time. If you have not done the journal activity yet, or have not gone and retrieved your journal, now is the time. Or if you don't have your journal with you, you can get a piece of paper, a pencil, a marker, a crayon, something to write and draw with. I'll give you a moment to go get that, and then we'll come on back and we'll talk about your journal. All right, so our topic this week is draw a picture of a star constellation or a star. What is a star? Does anybody know what a star is? Yeah, it's something you can see in the sky. Yeah, you see it. You see them at night. We see the faraway twinkling stars at night. But there's a star that we can see during the day. That star is the sun. The sun is actually a star, and it's the closest star to the planet Earth. Even though it's close, relatively close, it's still very far away. We're talking about interstellar distances. It's close to us, but in actuality, it's about 93 million miles away. It's a very, very, very long distance. We cannot reach it through conventional means. So if we were to drive a car, if your car could drive in space at the top speed of most cars, about 100 miles an hour, it would take you several hundred years actually to reach that far. You need a rocket, something that can propel you at thousands of miles an hour to reach it in any sort of time that we can easily measure or distance, that sort of thing. So the sun is very far away, as all stars are. But what is a constellation? Well, a constellation is a grouping of stars in space. We can see them at different times of the year. These groupings, these constellations all have names. A lot of them are taken from Greek, ancient Greek. So Cassiopeia, Orion, Taurus, those sort of things. Those are all constellations. And for you children, a constellation is kind of like a picture you can draw with stars. So some of them you'll see Ursa Major contains the Dipper, the Big Dipper. So Ursa Major, the Big Dipper is in there. It looks like a kind of a soup handle if you take your finger and draw and connect those stars. So when we come back to the Playsium, you'll see that in the light room on the wall, there are actually some constellations on there that I made with glow-in-the-dark stars. So hopefully you guys get to see that soon when things are back in order. So that'll be neat for you guys, and you'll know what a constellation is. You can check those out. But what I want to do, since we're kind of on that subject, talking about space, is let's talk about the contents in your last kit. The last kit you'll be getting has some activities you can do. The first one will be week 16. Week 16 has what we call calling a tinker kit, okay? It's this little fella here. And inside there are beads and laces and pipe cleaners, some of those stars I was talking about, glue, and this, along with this bag here in your kit, or your bag, you'll find all these loose parts, okay? And what we'll do with these is you'll create your own satellite, okay? Make your own cool satellite. You can add bits and pieces that are in here. You can add things from home. Maybe you have some costume jewelry or some really smooth pebbles or rocks or really anything. That will be week 16's activity. If you look in the bag, you also have an instruction sheet that talks about some of these activities. So you can look at that and read that as well. Week 17, we'll be making some painting. There's paint cups. Okay, some paint cups here. I have dark construction paper. Okay, this will represent space. Right, space is very dark. Right, and some paper here. What you do with this paper here is you'll cut out a circular shape. Okay, because we're going to create a moon. That was our journal activity last week, was to draw a moon in your journal. But this, with week 17, gonna make a moon, right? So you draw a circular shape out of there, right? And there's some glue and things you can attach that to. And then there's some foil. And this foil that's loose in there, this is actually going to be our paintbrush, right? So mine's folded up here, so I can put it in the bag easy. But once you get out of your bag, you can unfold it, and then we're gonna crumple it down, just like this. Right? And what this will do is now we've got kind of a crumply ball, a little smooth on one side, a little flat on the other. But you can see there are lots of ridges and dips and craters. And we're gonna use this, dipping in the paint, to create kind of like a surface, a textured surface, right? Because the moon is not flat, right? The moon it's not smooth. There's a lot of crater impacts from asteroids and meteors and things. And using this as your paintbrush will help you create your own unique surface for your moon. Right? So you have your paint, your paper, and your paintbrush. And the last week, week 18, has the bag here. Now what you see here in this bag, very simple items. You have some yarn or string, a straw, and a balloon. What you will need in addition to these things is a bit of tape. So some masking tape or Scotch tape you have at home. Tape of any sort should work. What we'll need to do is you want to cut your straw into about 2-inch lengths, okay? In your bag should be all that stuff there. And we'll cut into 2-inch length, right? And that straw is going to attach to the balloon, okay? You'll thread your string through that little bit of that straw there. And what this will do is this will create a balloon rocket, right? How do we get in space? We need rockets. Well, this will allow you to examine propulsion, right? And propulsion is when a force propels something forward. In the form of the rocket, you're gonna fill the balloon up with gas. So you inflate it, right? Pinch the neck shut. And when you deflate it, the elasticity in the balloon will squeeze that gas, that air out through the opening, right? And that force of the elasticity squeezing the air out will propel your balloon forward, right? Or propel your rocket forward. So it's a very rudimentary style to see how a rocket works, right? You can do it before you attach it to your straw, and you kind of predict and make a prediction of what will happen, right? And then I won't ruin the surprise for you. And then when you attach it to the straw, you have a more controlled experiment. So that'll be week 18, right? So you have your balloon rocket there. Have our moon painting here, right? And your tinker kit to create your own satellite, right? When you make your satellite, you can set it up and you test its balance, right? You can also set it on a small table or something you can kind of shake, a chair, right? Testing its balance, and then you shake that chair gently or that table gently, and you call it the shake test, and see if it will tip over or anything will fall off. Those are common exercises when NASA engineers are building satellites and rockets to do a shake test, a spin test. So that's one way we can test your satellite to make sure that the engineering will allow it to hold up to the rigors of space and space travel. Those are the last items that we'll get to have in your bag. I'm going to read a story with you guys, all about planets, right? This will be the story for this week. There may be more stories to go along with the next few weeks as well, but this is the story for this week, and this is called Every Planet Has a Place. Right? See right there? Yeah. What planet do we live on? Yeah, that's right, planet Earth. Planet Earth is the third planet from the sun. If you're talking about the order of the planets, you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And depending on who you ask, Pluto would be considered the ninth planet. It was when I was a child. But scientists have gone back and forth, and now they call it, some call it a dwarf planet. It has an irregular shape and an irregular orbit. The jury's out. You decide for yourself. Is Pluto still a normal planet, or is it a dwarf planet? So, we'll read a little bit about this story. Might get through the whole thing, and then we'll do our goodbye song, and that will end our day for this week. All right. Every planet has a place in space. Okay? These are the planets in our solar system. Okay? Now, a planet is a round object that circles or orbits a star. So think about all the millions and billions of stars out there. There are more planets. The planets race one by one in their rings around the sun. See, that's the order we were talking about. Mercury is the smallest planet. Venus, which is the brightest and hottest planet. Earth, where we live and has liquid water, it's the only planet with liquid water. Mars, which is the last of the rocky planets. It's actually the closest planet to Earth, and also is the tallest mountain. Okay. You have Jupiter, which is the biggest planet. All right. Saturn, which is the second biggest planet, and has those distinct rings, right? And all four of these gas giants have rings, but Saturn's are the most distinct and visible, okay? You have Uranus, which orbits or rotates very differently. The other planets rotate in about a circle, right? But Uranus rotates on its side. It's a weird planet, right? The last is Neptune. Okay, Neptune has a cloud on it called Nimbus that flies around at about 1,200 miles per hour, right? A lot of winds, right? The sun's a star so hot and bright. It sends us lots of heat and light. Okay? And the cool thing about the sun is that we all, you, me, moms, your dads, your cats, your dogs, everything in our solar system is made up of exploded leftovers from ancient stars. We all have space dust in us, right? The same elements in those stars are in our bodies. Pretty cool. Okay. So nearest the sun are 4 planet worlds made mostly of rock. We call these the interior rocky planets. Planets I was talking about. Give you a little bit of facts about them. Cool thing about Mercury, if you weighed 70 pounds on Earth, so a lot of you kids, some of you aren't quite there yet, right? But you would weigh a lot less on Mercury. Interesting, right? And the cool thing about Mercury is one side always faces the sun. So it's very hot. It's about 800 degrees on that side, Fahrenheit. And one side always faces out into space. Mercury is tidal locked, right? So it doesn't rotate the same way other planets do. Kind of neat. The third, our Earth, has just the right spot. Not too cold and not too hot. Life as we know it exists on Earth because of liquid water. We get just enough light and heat from the sun for life as we know it to grow. Pretty cool. The asteroid belt comes next. The asteroid belt is mostly rocks circling the sun. Has one dwarf planet mixed in amongst all those asteroids. Okay? Ceres. See? Right there. Out beyond the asteroids, 4 gas giants whirl. Right? We talked about those. See? Jupiter, Saturn, Uranus with its funny way of rotating, and Neptune. They have wild weather. Okay? Now these are gas giants, and they're not solid. You know, as a planet, it has a solid core, but all the stuff here we see is gas. Okay, wave your hands to the air. Okay, you can't see it, but you wave your hands through gas. There's oxygen and nitrogen and carbon. Okay, those are all gases, or carbon dioxide, I should say. Gases here on Earth, and these are gases we see on Jupiter, methane, nitrogen, other things like that. Right? But all that gas, it still weighs a lot more than Earth does. In fact, Jupiter is about 300 times bigger than Earth. Right? See this big spot here? Call this the Great Red Spot. That's a hurricane, a storm that has been raging on Jupiter for at least 300 years. We say at least 300 because that's how long we've been able to see it and see Jupiter. So could be longer. We don't know yet. All right, those gas giants have tons of moons all together, and enormous rings that swirl. So again, we're talking about those rings. They all have rings. Just the Saturns are the most visible. Right? And they all have moons. In fact, some of those moons for those planets are bigger than Earth. Do a couple more pages of this book. What comes next? What's the Kuiper Belt? Full of comets and rocks and dwarf planets hiding like toys in a cereal box. So out beyond those gas giants, in the belt, that's where we get comets, like Halley's Comet. They all come from that area. You'll find Pluto and Eris, right? Dwarf planets. These actually are smaller than our moon, but they're still a planet. All right, what you see in this picture here is a picture of the Milky Way. That's the galaxy we live in. Okay, and the type of galaxy this is, it's called a spiral galaxy. So all these arms, tentacles, okay, these are all billions and billions and billions of light years apart, and billions of stars are in all of those different areas. Right? And that's just our Milky Way galaxy. See? A little dot right here? That little dot is where our whole solar system sits. So our sun, our star, and the planets in our solar system are just that little dot right there. It's nice to know in our corner of space that every planet has a place. These gas giants are way bigger than these little rocky planets. That's the end. So, thank you for listening to me talk about solar system and space. I appreciate your time. Let's do our goodbye song, and then we'll finish our day. So everyone, let's get our clapping hands out, and we'll rub them together, okay? Space is very, very cold. There's not an atmosphere to hold any heat for us out there, so let's warm our hands up. You're going to space to be very, very cold. So doing this creates friction, which produces heat. All right, there's some physics going on right in your hands, right here. All right, here we go. Goodbye, friends. Goodbye, friends. Goodbye, friends. We'll see you next week. All right, guys, as always, thank you for joining me. Let me be a part of your morning. Stay safe. We'll see you next time.